Welcome to Bagh School. This is Physics Department. Students, we are in grade 11 and today's lesson number 21. We are talking about self-induction. As in the previous lessons, we have discussed the electromagnetic induction, then mutual induction, and then example of the transformer, which is the application of mutual induction. And today we are going to discuss the self-induction. We have already discussed that when there is a change of magnetic flux in a coil, it induces an EMF and current into that coil. So if we have a single coil, like in this example, and we are passing the current in this coil, the current is alternating current, which is changing at every instant. Then according to the principle that when there is current passing through the conductor or coil, a magnetic field is induced, magnetic field is produced around the conductor and around and inside the coil. So in this case, the magnetic field is produced, as we have already discussed. The magnetic field strength will be stronger inside and weaker outside. Now, when the current is changing, the magnetic field produced around this coil will also be changing. And at the same time, there will be change of magnetic flux in this coil itself. So when there is change of magnetic flux according to Faraday's law, there must be an induced EMF produced. So changing magnetic flux in the same coil will induce an EMF which will be opposite to the EMF supplied according to Lenz's law. So self-inductance is defined as the induction of a voltage or current in a current carrying wire when the current in the wire itself is changing. In the case of self-inductance, the magnetic field created by changing current in the circuit itself induces a voltage and current in the same circuit, same coil. Therefore, the voltage is self-induced or the current is self-induced current. Now, the principle of the self-inductance is based on the Faraday's law of electromagnetic induction. The flow of electric current through a conductor creates a magnetic field around the conductor whose strength depends on the magnitude of the current. A change in the current causes a change in the magnetic field from Faraday's law of induction. Any change in the magnetic field through a circuit induces an electromotive force, EMF or voltage in the conductor. This is known as electromagnetic induction. So the changing current induces a voltage in the conductor. This induced voltage is in the direction which tends to oppose the change in the current as stated by Lenz's law. So it is called the back EMF. Due to this back EMF, a conductor's inductance opposes any increase or decrease in electric current through it. In other words, we can say that the self inductance is the amount of resistance which causes to stop the any change of magnetic flux in itself. So if the current is changing, magnetic field is changing, magnetic flux is changing, so an opposite force is created in it in the form of induced EMF, induced current, which produces an opposite magnetic field which try to stop the changing magnetic flux. So in other words, we can say it's a kind of resistance of the inductance. So self-inductance is a special case of mutual inductance, and because it is produced within a single isolated circuit, we generally called self-inductance simply inductance. The basic unit of measurement of the for inductance is called the Henry, denoted by capital H after Joseph Henry, but it is also has the unit of Webers per ampere. So 1 Henry is equal to 1 Weber divided by ampere. So it is denoted by capital L, and the formula for the Henry as inductance is VL divided by di over dt. So if we apply 1 volt across the inductor, due to which 1 ampere per second current is changing in the conductor, then the resistance opposed, resistance produced, or inductance of that conductor will be 1 Henry. I would say again that it is same kind of the resistance which resists to flow of current, but self inductance is the opposite force or measurement of the resistance which try to stop any change of magnetic flux into the conductor, and it depends upon the applied voltage, current, and the rate of current at which the current is changing, increasing or decreasing, due to which the magnetic flux is changing. So dear students, in this lesson we have learned that what is self-inductance, principle of self-inductance, its formula, and in the next lesson we will try to give you some problems. Thank you very much.